You know those problems that are just impossible? The ones with so many moving parts, so many conflicting goals, where finding that perfect solution feels completely out of reach? Well, what if I told you some researchers have come up with a brilliant new way to solve them? They've basically created a tiny, specialized team of algorithms that learn from each other. It's a really cool idea, so let's get into it.
So, here's the game plan. We're going to start with a puzzle that probably sounds pretty familiar. Then, we'll look at the super high-stakes version of that same puzzle. After that, we'll unpack the genius behind this new 3-task team approach, see how it actually performed, and finally, zoom out to see what this could mean for problem solving everywhere.
All right, first up, let's start with something we all get. Every single day, we're making tough choices, trying to squeeze the best possible results out of what we've got. And that, right there, is the heart of optimization. I mean, just think about planning a vacation. It's a perfect example. You've got all these things you want, and they're all kind of fighting with each other, right? You want it to be amazing, but you also live in the real world with real limits. You're trying to max out multiple goals: affordability, excitement, relaxation, while staying inside your constraints, like only having 5 days off and a $2,000 budget. This is basically an optimization problem. And the real challenge? Finding that perfect balance. Okay, so now let's scale that way up. Instead of a vacation, imagine you're designing something like a robotic hand or trying to manage an entire country's power grid. Suddenly, the stakes are a lot higher, and those trade-offs get unbelievably complex. So in science and engineering, these kinds of puzzles have a formal name: Constrained Multi-Objective Optimization Problems, or CMOPs for short. You're not just juggling one goal, you're juggling a whole bunch of conflicting goals at the same time. And you can't break any of the fundamental rules while you do it. Now, the ultimate goal when you're solving these things is to find what's called the Pareto front. You can think of it like a menu of perfect compromises. Every single solution on that menu is a winner in its own right. You literally can't improve one aspect of it without making another aspect worse. And this is where the real challenge comes in. See, if you just ignore the rules, you get this beautiful set of ideal, unconstrained solutions. But the moment you factor in the real-world constraints, the entire picture can change. The best possible dream solutions might be totally impossible in reality. So the big question is, how do you find those real-world solutions without wasting a ton of time? Well, this is where our new algorithm, MTOEA, steps in. It's a completely fresh approach to cracking these tough problems. The thinking behind it is actually pretty simple, but really powerful. It says, hey, instead of looking at one giant problem as the single massive beast, what if we could break it down into smaller, related tasks that could actually help each other out? At its core, it's kind of like a divide and conquer strategy, but with a really cool twist. It's not just about splitting up the work. It's about creating a team of specialists that are constantly talking to each other and sharing what they learn along the way. And to make this whole thing easier to understand, the researchers came up with this great analogy. They call it the 3-task team, where each member of the team has a very specific role to play. So, meet the team. You've got the project manager, who's the realist. You've got the blue sky innovator, who's the dreamer, and you have the constraint specialist, who is the expert troubleshooter. Okay, so task 1, our project manager, has the main gig: solve the actual messy problem with all its goals and all its rules. But at the exact same time, task 2, the innovator, gets to just ignore all the rules. Its only job is to dream up the absolute best case, pie-in-the-sky solutions with no limits. And then we have task 3, the specialist. This one has a laser focus. It doesn't care about solving the whole problem. Nope. It focuses only on the trickiest constraints, the specific rules that are making those ideal dream solutions impossible. And here is where it gets really clever. How does the specialist know which rules are the trickiest? It just looks over at the ideal solutions from the innovator and figures out which rules get broken the most often. It puts all of its energy right at the point of greatest conflict between the dream and the reality. This collaboration is what makes the whole system work. The innovator shares its ambitious ideas, pushing the project manager to aim higher. The specialist shares its clever workarounds for the toughest roadblocks. This whole process is called knowledge transfer, and it gives the project manager the exact insights it needs to solve the real problem way more efficiently.
Okay, so it sounds great in theory, but does this team approach actually work? Well, the researchers put it to the test, pitting it against all the other top algorithms out there.
And they really went for it. They tested MTMOEA against 10 other leading state-of-the-art algorithms, and they ran them all on 32 different, really difficult optimization problems. And the results? Well, they were pretty clear. As you can see from this chart, the new team-based algorithm just consistently found better answers. It pretty much outperformed the competition across the board.
So why is it so much better? It all comes down to efficiency. It's smart. The algorithm has this built-in strategy to tell the innovator, hey, your ideas aren't helping anymore. Take a break. And the specialist is constantly refocusing on whatever the biggest roadblock is at that moment. There's just no wasted effort.
But look, this is about more than just a faster algorithm. What this research really gives us is a powerful new pattern for how we can think about solving pretty much any complex problem. The real takeaway here is this idea of collaborative intelligence. I mean, breaking down big problems isn't new. We all do that. But creating these specialized roles, a dreamer, a realist, and a troubleshooter, and then making them constantly share what they're learning, now that is a recipe for a real breakthrough. Which really just leaves us with one final thought. Think about your world, your job, your community, maybe a personal project. What's that one impossible problem you're facing that you could finally crack if you just assembled your own project manager, innovator, and specialist?